Hello, everybody. Welcome to OpenCV weekly webinar. We have an exciting show today with Jesse Brockman, who led Midwest Defenders in OpenCV Spatial AI competition sponsored by Intel and Microsoft Azure. Jesse is a senior software engineer and the winner of SparkFun Autonomous Vehicle Competition in 2016 and 2017. And I wish Jesse all the best for 2022. Very close. His team is in the top 10 of the OpenCV Spatial AI competition. Welcome, Jesse.
Hello. Good morning or afternoon, wherever you are.
All right. And also with us is Phil Nelson, who is the content manager at OpenCV. And he is responsible for putting up this show as well as a lot of things at OpenCV. Welcome, Phil.
Yeah, good morning, everybody. Once again, it is I, the co-host with the co-most, the second banana who is second to none, the next best thing, Phil Nelson, once again here to remind you, this is OpenCV Weekly Webinar, episode 53. We've done over a full year of these weekly shows now. There's a couple of things we do every single week here, one of which is a giveaway to you in the audience. At the end of the webinar, I'll be asking a trivia question, which you'll be able to answer if you're here in the Zoom audience. You will get $200 of Microsoft Azure credits from our sponsors on blazing fast Intel hardware. If you answer that question correctly, stay tuned for that. We'll also be doing Q&A from you here in the audience, so use the little Zoom Q&A button in the bottom of the screen at any time during the webinar, and we'll try to ask your question if it flows into the conversation. We'll also save time at the end of the episode for any questions we don't get to, hopefully. We've also got, I hear, a special discount code from SparkFun, thanks to our generous guest here, Jesse, so stay tuned for that.
That's great. So Jesse, let's start with a quick introduction, and then we'll go on to see the amazing slides, amazing project that you have done for OpenCV Spatial AI competition.
Thank you, guys. So my name is Jesse Brockman. I am a SparkFun brand ambassador, and I'm also a software engineer for a very large company. I've taken the Audacity self-driving car engineer program, and as I said, I've actually competed in the SparkFun ABC between 2014 and 2017. My teammate, Ted Myers, is also a software engineer based out of Colorado. And it's kind of how we got our name of our team, because I live in Iowa and he lives in Colorado. So we're both kind of in the Midwest. And also the Lego rover that we're using is actually a Defender model. So it's a Lego Land Rover, and the model name is the Defender. So I call it the Lego Land Rover Rover, LLRR for short.
Sweet.
Wasn't that the name of one of the evil alien guys from Futurama, Lur? Ruler of Omicron Persei 8?
You would know better than I haven't watched it 12 times each yet.
All right, show's yours, Jesse.
All right, so I'm gonna share my slides here. Oops, just a second. Forgot the audio. Share sound. All right, let's go slide 1. This second. My slideshow is on wrong. Oops. I'll go to the first slide.
It's an exciting preview of things to come for
yes,
the audience.
Very quick. So here's our Lego rover before any of the autonomous parts have been added. So it's got this white roof on it, and you can see over here on the left a little bit a stop sign that we 3D printed, and I'll go into details. So this is what the box looked like when you get it. Yes, it is 2,573 pieces. It's a rather large build. They claim you can do it in around 13 hours, but I also had to add the electric motors and other modifications. So I have more like 30 or 40 hours into that. So here's a good start. This isn't by any means all the pieces, but you can see exactly what we're looking at here. It's quite a challenge with all those pieces.
I think the technical term for that many Lego pieces is a shit ton.
Yeah. Well, it also known as what have I got myself into?
Yes.
So here you can see it with the main chassis assembled with the electric motors in it and the gearbox. At this point, we're moving along good. So here you can actually see the electric motors under the hood. This does not come this way stock from Lego. I use the rebreakable instructions and then purchase the motors and other components necessary to make it motorized. So here you can see again my finished rover. Yeah.
One second, if you go back to the previous slide, some people may be very interested in when you're showing the motor. So you go from this Lego set doesn't come with the motors, right? You just
that is correct. That is correct. It
how
comes just.
How do you modify it? Are there instructions out there? Have other people done it to motorize it? How does one go about taking this, essentially a toy and making it motorized?
There's instructions set out on Rebreakable. So if you go out to the Rebreakable site and you search for the Lego Land Rover or the Land Rover Defender model, there's a couple different instructions on how to make it motorized. They use the Lego servo and I don't, and I'll go into a little bit of detail about that.
I've got that link. I'll drop it in the chat and make sure it's in the show notes for everybody.
All right, that's great.
So here you can kind of see the modifications that I made to the rover. Up front in the lower part there, you'll see a standard 20-gram RC servo and a 3D printed bracket to hold that onto the Legos. I did use hardware screws, but really because of the amount of torque that the servo was able of generating, I felt it was a better solution than trying to do it with Legos. Then in the middle, we have an encoder and a magnet. So it's a Hall effect sensor that each time the magnet does a rotation, it sends a pulse to the encoder. I use that to get the distance traveled by the rover. Then on the top side here, we can see over on the left, we can see the USB battery bank. Then we have the OT light, which is up high on the top of the rover. Then we have an IMU used for dead reckoning for navigation. Then we have a teensy in the middle, which is with the board that I designed. And then on the back, we have a Pi 4B with a heat sink and fan because they do tend to run a bit warm. Now here is the other side of the rover. Well, actually, this is the same side, but here you can see the USB battery bank at the top and the teensy and the gearbox.
IMU was that?
It's a B&O 055 from Bosch.
Okay.
The thing that's good about the B&O is that it will give you a heading data directly. You don't have to read the angle, velocities, or accelerations and then get a heading. It'll just give you a yaw angle straight out of the IMU.
I see those Bosch IMUs getting used a lot, and that may be one of the reasons. They're just very capable.
Yes. The drift on them is very low. So over the course of my runs, the angle heading change is very slight. The error is very little. So here's the other side, and you can see the ESC and then some of the other components from this side. I'm not going to focus on that. So here is what the rover looked like when I'm actually driving it around. You can see it in the background here. You can see it. I have the top off just to give me easy access to electronics. Then in front here, you can see the signs that I'm actually using, and then what I'm calling markers or poker chips in front. They're 1.5 inch in diameter. I got the larger ones just to make that have a ridge to make them easier to see when they're laying on a carpet or on a floor. So after I had the Lego rover built, it was time to take pictures. When I say I took pictures, I took hundreds of pictures, all angles, different lighting levels, different order of signs. And then you have to label all of these so that your AI is able to train on the data. So it's a very arduous process. There are ways of increasing that time, decreasing the time by certain augmentation, etc. But so for each one of these pictures, I have to label each individual sign. So it's a long process. And then I have the same thing here for the markers. And the only thing to point out in this image is the lower right-hand corner is a null image. It's a very important part of training your AI to have null images, or else you will have more false positives than you want. So make sure you have some null images. And the suggestion I've been given was to take it of the same scene that you're taking for the other images so that it will be very much in line with your training.
Yeah, what did you use to train all these? Once you generated all your images, what software did you use to actually train?
Sure. So first I tried using a Python program called Label Image to go out and label my individual images.
Very
And
familiar with that
so
one here.
So it'll create a markup file for each file, and then you could use that to train your AI. But of course, you have to get all your files set up, and it doesn't do any augmentation for you. So in this way, it'll allow you to do it in an offline manner. But it's very arduous and tedious process to get the files in the right format, etc. So I switched over to RoboFlow. For those who are familiar with it, RoboFlow or not, RoboFlow is has the ability to do a lot of the steps for you. So what you can do is just drag your images, and if you have existing tags or labels, you can upload those here as well. You can also even upload videos. So you can just walk around or drive your rover around or whatever and take a video, and then you can pick how many frames per second you want out of those images and upload them to RoboFlow. And
Yeah.
then RoboFlow has a very similar UI to label image, where you can go in here and you can highlight an individual sign or object and then pick over here what type of object it is. And then that'll do that all for you. Once you have this set up, then once you have that, then you can do some training in RoboFlow if you have credits available, or you can also click up here and do the export. When you do the export, you can then pick what type of format, and I'll show that in a second. But the important thing about this down here is that we have total 3,000 training images. Now, I didn't actually take 3,000 pictures. I actually took around 300. And what I'm doing is using a ability that RoboFlow has called augmentation, and I'll get into that in a second.
That's
Some of your data is also
briefly. I'll interject. That's OpenCV's silver member RoboFlow. And if people watching out there would like to try RoboFlow for themselves, they can do that at roboflow.com/OpenCV.
Yeah, one of the things that it's maybe we did not do a good job of explaining people who are in the competition and starting out is that because of the limited time in the competition, RoboFlow is a great solution. Because you get started, etc., very quickly. Especially, you have the annotation part is there, and also you can train something very quickly. A lot of people ended up doing that. But if you had explained this at the very beginning, I think it would have saved people a lot of time. So
Yeah,
something for us to do next time.
absolutely agree.
So then you want to have some of your data set aside for validation and testing, and RoboFlow again will do this automatically for you. So you can set your percentages on that. And if you don't like it, you can easily resample it and change those. So one of the important part is when I said I only had 300 photos, why did it show that I had 3,000? And that comes down to augmentation. What augmentation does is it takes your images and changes, say, the angle of the image or the brightness, or makes it slightly blurry, or the exposure. And this allows you to train on a more robust set of data than what you actually took. So instead of having me have to take 3,000 photos, I could take 300 and then use augmentation. The default for RoboFlow is a little lower than the number of augmentations I was using, but you can certainly discuss with them and they may be able to change that for you. They're very friendly.
Yeah, feel free to shout out if any of the support team helped you out. They love hearing their names.
Mohammed Tior was the one I spoke to most.
Shout out to Mohammed. We talk on LinkedIn sometimes.
He's actually local to me here, so I've actually met him in person. So thank you. Then once you have all your data, you need to do something with it. In my case, I first started with MobileNet SSD, and I've been told that you should spend more time working on your data than your code, but I decided after one day to switch from MobileNet to DarkNet, YOLO V4 Lite. So inside of RoboFlow, you're able to just pick the format of data you want. For mobile SSD, I was using the TensorFlow TF record, and then I switched to YOLO DarkNet for my export option. So YOLO DarkNet, if you're not familiar with it, is a package available out there on the internet that you can download, and then you're able to use that for training. So you just export the data from RoboFlow, configure a couple files to point at that data in darknet, and you're ready to go. So then once you have everything set up on your machine, you need to actually start training your data. You can also do this in the cloud using Azure or some other method, but I have a 3060 Ti, so I decided to use that to do my local training.
One of the few, the lucky few. I think about 12 people have one of those.
Yeah, it's difficult to find GPUs these days.
Still.
I bought a Dell that happened to come with it. So as long as you're willing to pay a bit of a premium for the brand, you were able to get one.
That's smart. I've heard of a couple folks saying like, just I had to buy a whole other system I didn't intend to use just to harvest the GPU out of it. Yeah.
I was ready for a new machine anyway, so it was okay. And I actually did okay because I actually mined crypto with it for 6+ months. So I made most of my money on the machine back just in doing crypto. So.
Right on.
So once the data is trained, you'll train for many hours, and then you have to look to see how the data went. But I'll get into more details about that. So my setup, I used Anaconda for Python because there's a lot of dependency issues you can get into with Python, and Anaconda will help manage those for you. Then the next one is Colab Jupyter Notebook that was provided by Luxonis that gives you example code and pretty much everything you need to train a YOLO darknet neural network. And the cool thing about the Colab from Google is it's actually free to use, and you have enough resources. If you don't have a computer available, you may actually be able to do your training there. And they have higher classes if you wish to pay for them.
Yeah,
Then
just a word of caution that for YOLO, etc., it's fine. For if you want to train longer, then then it can just get disconnected, things like that. So you have to make sure that when you're training with Colab, you're saving checkpoints and things like that, so that you can resume your.
Yeah, it'll die in I think 24 hours for paid ones, something like this.
Well, for the free ones, it can die in 8 hours, but
Yeah.
sometimes you get there are other kinds of things happen. So whenever you use Colab, make sure that you're saving the checkpoint so that you can start from there if something bad happens.
Then the next one is the darknet link, but it's also available to the Jupyter Notebook. Luxonis has really good documentation on how to get started with the OD or OD Lite, and I really recommend you start there. I started from one of the C++ examples to create my code that I was using, but I also tested it first in Python to make sure everything was working before I spent the time writing the C++ code. But honestly, the YOLO v4 example available from Luxonis is very good. So once you have your neural network trained, you actually have to get it into a form that can be used by your OD Lite. And so there's a 3-step process, which is also documented on that Jupyter page. But the first step is to convert it into a PB file. I don't remember exactly what PB stands for, but
yeah, it's a binary. Yeah.
So once you've created that file, then you have to convert it into OpenVINO format. This OpenVINO format is then actually converted then by the blob converter into a blob for use on your actual device. So again, on that page, I link with the Jupyter, it goes through these various steps, and Luxonis has very good documentation on this. But it's important if you want to actually run on your hardware that you must go through these steps. This is a graph that shows you actually how the training went. And as you can see here, the recommended is 2,000 batches for every labels, and I have a total of 9 labels, so I did a total of 18,000 batches. However, if you look at the actual training data, you can see here within 3,600 to 4,000 iterations, it's already very close to the ultimate accuracy. One interesting thing about darknet is it will always save the best weights at each 1,000 iterations. It'll save each 1,000 iteration and then keep a separate one that has the best training data. As you learn more about AI and neural networks, what you really need to think about is underfitting or overfitting, and both of those can be issues. So if you didn't have a lot of time, you really could stop at around 2,000 iterations here and have a very good solution. You don't really need to spend all 18,000 iterations. So I did this training, I created my blob, and this is the very first image I have of it actually recognizing the signs. You can see here, I have reserved parking, no parking, stop signs, left and right turn signs, and U-turns as well. This one image here is in the back is kind of obscured by other signs, so it's not actually detected. You could actually work in your neural network and train with more truncated image, and eventually it would be able to find it as well. So once I had that done, it was time to actually take my neural network and do something with it. So I created this program called Midwest Defenders Control Program, and this is basically a curses-based UI. So it's a text-based UI, and the idea of a text-based UI is it's a very low bandwidth. So you can send it over any line, like even a modem or even like a cell phone or something. So it's very low data rate. So it allows you for very high frame rates, and if you have a low data rate, it'll work fine.
Yeah, people used to use these on 56K modems.
Before we move forward, I have a quick question.
Yes.
How would you rate your knowledge of AI before this competition? Did you know, had you trained a model before? I mean, what was your level of knowledge of AI?
Sure. When I took the Audacity class for the self-driving engineer program, we had to do a demo where we had to take a car and drive it around manually using a joystick or keyboard commands. And then we fed that into an AI and used that AI to actually drive the car. So we actually did have to train an AI there. And the idea was that for each image that the AI would see, it would have to make some idea of what steering angle or what command to send to the car. So it determined if it could go straight or turn left or turn right. So I actually learned about AI through that Audacity class. And we had several other training sessions on AI as well about recognizing text or images or signs.
Mhm.
And so that was really where I got my experience on AI.
That's great. So you did have, coming into this, you did have some background in AI.
Yes.
All right. Okay, cool.
So this
Those
program
online
allows
courses, by the way, are a great way to get started, just like the ones we have at opencv.org/courses.
Thanks, Phil.
So this UI allows me to record images or videos, and it also allows me to see real time what the AI is doing. So we'll get to that in a second. So this is actually an image from the AI that's been blown up when the rover is actually navigating. So you can see here that it labels the stop signs, the certainty, and the distance in Z. X and Y are really determined just by looking where they're at in the image. So I don't really display those. It's extra data. And for the markers, if you have a lot of markers on the screen, it would take a lot of data. So I just marked the location of markers, but I changed the color to green to indicate it is in fact a marker. So in this image, you can see both the left turn and the stop sign are seen with a very high certainty. And the distance is also to the signs, which is where the spatial part of the spatial eye comes from, the X, Y, and Z coordinates of the actual objects detected. So this is actually a recorded output from a run. What this shows you here is actually the dead reckoning output from my rover. So you can see that I'm actually able to generate a 2D map of the navigation route. And you could actually then replay this in the rover. You could take away the markers and then actually replay the route. I did try to actually put the marker locations in here, but the data is slightly noisy. So there had to be some more fitting on that data to get a good location of those individual markers and signs. 3 months wasn't really enough to get that done.
So what we were looking at in the previous one is one of the green lines, not, sorry, the other one, the next one.
Yeah.
That you're showing that using, did you come back to the original location? And there is a little error in the end where it doesn't match up because of dead reckoning?
Actually, it has to do with the location of the sign. Actually, I'll show that in the live demo I plan to do in a bit here. I'm doing the exact same route that you see here, or very similar. So hopefully you'll see what it does. But yes, there is some error that occurs over time.
Yeah.
But when it's coming back, it actually aims directly for the sign towards the end. And I think the sign is just a little offset from the markers. And so I think that could be what caused that. But you can see in most of the path, the turns, like the right turns for the turn signs are very sharp, very much 90 degrees. And I think overall this is a good estimate of my error. But the good thing with using the tokens is that even if there is some error in your navigation, as long as you can see them, your XY position of the rover doesn't matter all that much. It
Yeah,
really is able to compensate.
Yeah, once you're near the marker, you fix your errors, whatever the error is, right? Because you exact
Yeah.
position. Okay.
So as I was doing this project, I also started to look at doing cloud point maps and take the depth image and create a point map from that, and then interpret the point cloud to determine where obstacles were in front of the rover. Again, I got kind of stuck with the timeline and I was not able to progress further, but this shows my hand above the OD light, and the shadow around that is actually the ceiling. But if you look here, the ceiling is very flat and you can clearly see my fingers in the image of my hand. So it's clear that there is a way forward. And I know there's examples also on the Lansana's website now of converting the depth map into a point cloud. But again, the time frame of the competition did not allow me to progress further. So I'm going to do a live demo. If any of you in the trade know, live demos, of course, are scary and nerve-wracking. So I'm about to give it a try.
Right. It's the bravest thing a
me for a
person
minute.
can do on this show.
You're gonna have to excuse me for a minute while I get the rover ready.
Yeah, it's all right.
Here is the rover ready to go. Let me turn it on and we will give it a shot.
Yeah, go ahead and unshare your screen, Jesse, so we can get the full view.
Yeah, I will.
Perfect.
I will actually share the screen that you see from the rover, so you guys will actually get a first-hand view of the rover.
Yeah, it's been a while since we had a live demo on here. I think was it last competition? It might have been Cortic.
Well, no, after Cortic Tigers, I think Gerald from he also did a live demo.
Oh, that's right, Team Kata, Gerard Spona, who is working on the Unity plugin for Depth AI currently. I've been meaning to try that out. It's really come a long way from in a short amount of time. I'm looking forward to it. Also looking forward to finally trying out RoboFlow. I embarrassingly have not actually logged into the account I have there yet, but this is making me want to do it some more because of the seeing those screenshots. It's that too has come a long way in a short amount of time. It seems very usable.
Yeah.
Okay, I'm back. I am just getting ready to launch the UI, and I will share the display coming off the rover in a second here. So what I have up right now is the UI. I'm not going to show it, but it's the same one that you guys saw in the slide. So I'm now going to share my screen, my display, and you'll actually be able to see my hallway in my house.
Okay.
Should be coming up.
All right, we see it.
Well, I already have a little bit of false detection there with the stop sign, but what I was going to say is the certainty is only 50 to 59%. The rover does not act on anything unless the certainty is over 90% and the distance is more than 100 millimeters and less than, say, 1 to 2 meters. So these false positives are really the kind of thing you need to see to know how to retrain your AI to make sure you don't have them, which is why I show them.
And those numbers are basically magic numbers that you kind of figured out through trial and error, right?
Right. Yes, 90% certainty of a sign is a pretty good accuracy, and also the distance makes a difference on the accuracy. It may think with a very high certainty it's one sign, but if it's 3 or 4 meters away, it's wrong. So you can use that distance also as somewhat of an uncertainty measurement. The closer it is, the more accurate it is.
And just to, in case people, some of the audience may have missed, when you train the poker chips, they were on a flat bed. And the reason is that this is the view the robot is going to get. It is not detecting it this way, but lying flat.
You
Right.
want to be as close to what your camera will probably see.
Mhm.
Yeah.
And I actually did a lot of training also using the images from the camera itself, like eating your own dog food, so to speak, doing exactly the navigation with the same resolution, everything that the rover is using. I've scaled up the resolution for what you're seeing here. The AI actually uses 520 by 512 by 320 is the actual image resolution coming out of the OT, and then is doing the neural network on that. But I've scaled it up here to make it a little easier for you guys to see. So some of my computation time is spent scaling up the image and displaying it. Plus I'm running over Wi-Fi, so the frame rate is not going to be all that good, but it should give you some idea of what's going on. So I'm just getting ready to start to run now, and I will be at the mercy of the auto testing
Right.
gods.
It's exciting.
Like I said, the frame rate is
Okay.
a little low, and I apologize,
moving.
but it should be
That's
navigating. Funny story, while I was testing, at sometimes it would pick up false positive for signs, and the issue with that was, well, we have our first failure. But let's
Yeah, it's going headlong into that wall.
Let's see if it'll actually pick back up. It did.
Oh wow.
But now we hit the wall, so we'll have to reset.
Yes.
Give me 1 minute, 30 seconds, and
Yeah.
we'll try again.
No, the brave live demo is
Yeah.
I mean, it worked. It's somehow, in my experience, having done many live demos that have gone badly in my life, it's almost disappointing when it doesn't completely fail.
The law averages for me is around 50%. So we'll see if we'll try twice more and see if we can get it to work this time. But we're reset, ready to go again.
Sorry, I lost my headphones there for a sec.
I turned on another light in the hope of trying to.
It's moving.
Yeah.
Right here is where it failed last time. It didn't detect. One issue I'm having is glare. When I did most of my training and testing, I was doing it in the evening because I had to work during the day. So I was having less issues with sun glare. Well, we made it further than we did last time.
Yeah. Yeah, and we were talking before the show. You know, that's just the glare thing is just one more thing to augment, right? You know, maybe turn up the gain and.
Now it's going to turn right here. I have confidence that it will turn right.
All right.
Now we're into my kitchen, and it should pick up some marker here. You can see some of the glare here. I think we just caught it. Oh, and we hit the fridge.
Maybe it's
one more time, and then I'll go on to the pre-recorded demo that I've done in the past, so you can see it actually complete the course.
Yeah, it's also cool to see it from an external camera as well.
Yeah, I apologize for having these issues, but
there's no need to apologize.
No, it's
something accomplished.
Lighting conditions are tricky.
Absolutely. No, this is an accomplishment.
All right, so we will be starting for our third and final run here now.
We believe in you, Rover.
So while this is going, I can explain to you that I'm running at a different frame rate than what you see. It's actually running at 20 frames per second, and it's only updating the screen every, say, third or fourth screen. And it's transmitting that data. And so this is actually different code that I run in the competition because it has to scale up that image. And so while it's doing that, it can't do the recognition. So it's possible that one of the reasons this is failing because this isn't actually the code I run for my actual competition demo. But I wanted you guys to see the image instead of the small image that would be seen. So one way or another, you'll get to see a complete run, whether it be live or in a video.
The chat's loving it. We get great demo, excellent demo. David says, well, at least we know the demo isn't fake.
Thank you. Yeah,
Oh.
I could actually do peer pursuit and do dead reckoning, and I couldn't, once I have the path data, I could actually navigate it live. I think we're
All right,
gonna make it this
we got
time.
to the left turn. We're making it.
Yep, we're gonna make it.
That was a
I'm gonna go out and wave to the camera so you can see me live.
So
Love
that okay.
We did it.
Trust
We
you
did it,
now.
everybody. Incredible. Great demo. No notes. Great demo.
Thank you.
That was awesome.
Share, go back to my slides.
Yeah. The chat's blowing up. The chat's blowing up. Many awesome woohoo, hurrah, excellent demo.
Thank you. I didn't plan for the third one to work, but hey.
The third time's the charm,
whatever.
as my dad
Yeah.
used to say.
So let me get my screens rearranged here.
Always love a live demo. Sucker for a live demo. I feel it. It's, you know, this is a live show. Anything can happen on live TV.
Right.
Thank you. Do you now see the video?
I do not. I do not see your screen.
Okay, just a second.
There we go.
I'm going to show you the demo that I actually presented for the competition, so you guys can see.
So this is your final submission. This is what the one of the pieces of material that the judges are judging as we speak.
Apologize if it's too loud.
It's all right.
For the record, this is only the second time I've ever edited a video. This is actually in my partner's house, Ted Myers. This is in his kitchen. And I want to note, he was actually using the autofocus camera during this. So you'll see it get blurry a couple times when it's navigating.
Yeah,
which is why we switched to the fixed focus in future testing. There's a blur. And you also notice a lot of the times behind the signs we have boxes or something. It just has to do something with how OpenCV sees depth. If you don't have enough contrast or the sign is too small, it can't actually accurately determine the depth to objects. There's another blur because of autofocus, and it stopped right on time. Now this is the pre-recorded video I've done of my rover navigating. So this is a higher frame rate because I was actually recording images, and then at the end of the run, I take those images and convert it into a video. The frame rate is still a little low because I'm saving to an SD card and I'm saving compressed images, so it has to create the image, compress it, etc. And also explains a little bit of the delay with the markers. They don't always quite line up. And you notice there are occasional false positives where it'll pick something up or not. I got very close to hitting the objects there.
Yeah, but it recovered.
This was a brighter
nicely.
day actually when I did it, and I had a lot of problems with glare right in that location. So right after this video, I actually blocked off that little glare section there. Again, you can see some of the glare, and it's not picking up all the tokens, but it does pick them up just often enough for it to be able to navigate with the markers. And what I'll tell you is I don't navigate towards the closest markers. I do an average of multiple markers, and that's because if you're always going towards the one closest to the video, they're kind of swerve back and forth. And it's better to use what we call a look-ahead distance when you're navigating so that you have it smoother. Now I switch to following it with my phone so you can actually see it navigating.
This is one of the few times where the Hansel and Gretel method actually worked.
So this third location was at a makerspace locally, and what I'm showing here is a much longer run, consistency. So what you'll see is I'm showing you first how it's navigating, what course it's navigating, and then you'll see there's a U-turn in the course so that it will actually just keep going in a circle over and over again. And then towards the end of the video, you'll see what I do is I actually switch it from a U-turn to a right turn. So you can see that it is actually following the signs rather than pre-recorded navigation.
Right, it doesn't have foreknowledge.
Right. The only thing I'm really doing here is measuring the distance to the markers and the distance left or right of the markers. And then it's really literally just taking the current heading of the rover and adding and subtracting the angle to the markers. And that is done by taking the Z distance and the X left-right distance to the marker and just doing an arctangent 2, which gives me an angle, and then applying that angle to the current heading, and that is how it navigates towards objects. So we're going to speed it up here because this gets a little boring, but you'll see here that it continues to navigate. And again, I do have objects behind signs just to make sure they're properly detected. For distance, they'll see the signs, but the distance measurement will be wrong without those. Apologize if any get a little motion sick. So you can see here I did like 3 or 4 laps around here in a row, and it's continuing to navigate without issues. Again, I sped it up because nobody really wants to just sit here and drive around for all that time. And now I've switched out the sign magically while it was navigating on the other side. I switched out the sign for a right turn. And now it's going to turn right and start looking for tokens to pick back up and continue navigating. And it'll catch them over here a little bit to the left. So it'll turn towards them and then finish the course. So the funny thing is at the end of this video, the rover didn't stop through a command. The Lego rover itself actually failed because one of the Legos in the drive train decided to quit right here. So that was the end of it.
So you had to do an in-field repair.
Yes, in my long video, in my long presentation, I actually showed that I glued those pieces. So what's next for me? I went to the Indy Autonomous Challenge last year and I saw these Indy Lights car race in person. It was amazing. It was really something to see. I wish I could have seen the side-by-side racing that they had in Vegas, but I wasn't able to make it to Vegas to watch it in person, unfortunately. So I am building a Formula One 10th car. If you're not familiar with it, they're little slash-based vehicles, and there's open source software and hardware documentation available for you to build your own rover. So we can see here a LiDAR up front and then an OAK light behind it. I'm also working on an autonomous go-kart using very similar software. There, I'm going to need to detect people, go-karts, cones, and flags. So what I train my AI will be slightly different, but the AI will be used in combination with the LiDAR. The AI and the camera is more about safety, not hitting people, not hitting obstacles, stopping when it should. Every go-kart will be different. So you can't really train it necessarily on the go-karts itself, but one little trick I've learned, train for the tires. All the tires and all the go-karts are the same. So if you see the tires or maybe their helmet, you can recognize a go-kart, even though the shape may be slightly different. Tires are the same. Also have an autonomous lawnmower I'm working on, a little electric lawnmower, and similar. Don't want to hit birds or cats or animals or trees, etc. So the AI will be trained to detect those various objects and stop or navigate around them.
I wanted to add people too. You don't want to hit people as well.
Yeah, train some shoe detection there. Yeah, foot and shoe detection.
So that is the end of my presentation. I'd like to thank you all for listening. As you can see here, there's my discount code for SparkFun. It's Jesse B 2022. It's available through the end of the year, and it's good on any SparkFun original item for 10% off.
Great.
Awesome. Yeah, thanks for yeah, make use of that code, folks. That's a great great deal. Just for watching a cool video, huh? Let's go. You can go ahead and I'll post the code in the chat here. Jesse B 2022. Yeah.
Yep.
So one quick question. We know how, from most people will figure out once you have the Oak Delight and you go to Luxonis documentation and up to the image processing or the computer vision part, we know, all the steps. Now, a lot of our audience, we are not robotics people per se, right? So what happens after you get all this information on the Raspberry Pi? From there, what software do you use to control the robot? What are the various layers? What are the things people need to install to get this thing going?
So you need the software from Luxonis for actually working with the camera, which is called Depth AI.
Right.
And then depending on the route you go, whether it's C++ or Python, they will have documentation for you and example code that you could use to get your first AI up and running without you having to do any of your own training. I saw a couple quick questions. Shaves, I'm using 6 shaves. And how do I get 2 values for different signs at the same time? That's just part of the spatial AI and the depth AI UI. It will provide you any object it detects. Will give you the XYZ coordinates of any number of objects at the same time.
I've seen it work with quite a few objects. I don't know. I think there's a theoretical limit, but I don't actually know what the limit is for number of objects recognized on the Oak D. Do you know, Satya?
Well, it depends on the model that you want
Yeah.
to, right? But let's say, for example, if you use only YOLO, the original one, that's probably
That's right.
98 is the maximum.
Because that's built into the model. It's baked
Yeah, that's
yeah.
how the model works. But if you're using anything like YOLO V3 or above, it's plenty. I cannot remember the exact numbers, but they are in, you can identify a lot.
I bet if people wanted to go back to our episode about building a snowman detector, that information is probably in that episode of the webinar.
Right.
Let's go ahead and do our giveaway here. So for folks who have never done this before, or if you just need a reminder, one of the things we do here every week is a giveaway. This week, the giveaway is of $200 in free Microsoft Azure credits on blazing fast Intel hardware. The way this works is I'm going to ask a question that I've come up with from Jesse's slides, and you in the Zoom audience will answer that question in the Zoom chat window. The first person to answer the question correctly will win those $200 in Microsoft Azure credits. Please, if you have won in the last 2 months, do not answer and give someone else a chance to win. Get ready to answer out there in Zoom land. So, to train the AI recognizer, Jesse took 300 photos. Using the data augmentation tools on OpenCV Silver member RoboFlow's website and app, he was able to add many to that with a final number of what? Oh, you guys were on top of that one. I see John Little with the correct answer, which is 3,000. Congratulations, John. Please send one email to phil@opencv.org. That's my name at opencv.org, and we'll make sure that you get your $200 in Azure credits as a code. Congrats. We've got tons of questions here. People were really interested in how this little Lego rover works. Let's see here. From Wendy would like to know how much, at what distance do you start turning the car when it sees left, right, or U-turn sign, and how did you come up with that number in terms of when to start turning?
It was kind of based off of 2 different factors. One, I was sure this distance to the sign is what it thought it was. Can have some issues with left versus right turns until it gets close enough to really see enough pixels to know that really is a left turn or a right turn. And there's one little key with YOLO, it actually does a mirror of the image. So I had a lot of issues at first with it detecting left and right signs as being the same thing. There's a setting in YOLO called flip equals 0. Then it won't try to do any augmentation on the flip image. So it's something really, if you're doing something that's directional like signs, you need to be aware of. But the distance I came up around was around 1 meter. And the idea was that it's close enough to recognize the sign, but it's not so close that it's going to turn and hit the sign. So it's designed to be as sharp a corner as the rover could turn and kind of avoid the sign. So that's really how I came up with the distance. For whatever reason, stop signs are actually much easier to detect, and 1.1 meters, 1.2 meters is actually the stopping distance for stop signs, and it usually stops between 1.1 and 0.9 meters when it actually stops. And I will recommend also you have a minimum distance for recognition. If you notice when I was showing the video live, it detected a stop sign, but it said the distance was 0. So sometimes you can get, with false measurements, you can get a reading of 0 meters. So do not have just a minimum distance to your signs. Can include a lower end case. In my case, I did 100 millimeters.
Interesting. Yeah.
I just want to add one thing that in data augmentation, I always, when I teach to students, I always tell them that be very, very careful about data augmentation. You might be teaching it the wrong thing. And flip is the one example I give all the time. And a flip is, I had not known about this example. This is another great example, left and right turn. It can be flipped. The second comment I want to make is that in your environment, because the background is beige, yellowish, right? That's why it is difficult to detect the yellow signs. But
Versus red.
red, right? So it is very easy. It can just look at the color and say that, oh, there is, I was trained on this, and you don't see that. Yeah, so those are the two comments I wanted to make.
One interesting thing is I actually trained on green tokens, but the package I purchased from Amazon actually had multiple colors, and I didn't have enough of those. So I said, what happens if I try blue? It worked just fine. And what I was told is basically I didn't teach the AI to care about color. It was looking more at the pattern, someone at the color for the tokens. So if I wanted, I could actually create a different training set and do green token, blue token, and other colors of tokens if I somehow want to differentiate for those tokens. But as it stands, it doesn't. So it's not looking as much as the color to recognize those chips. But if that's important to you, you could set up your training data that way.
Right.
Thanks. Yeah, awesome. Great answers and great comments there, Satya. Michael would like to know, did you consider taking your training images from an OAK-D mounted on the rover directly?
Yes, when I first started training, I did not have the OAK-D mounted yet. I didn't have a completed rover. So those pictures that you saw were mostly taken before I had a rover up and running. But what I did is I actually drove the rover around. I looked for edge cases or conditions where it wasn't working. I would just snap a couple pictures. Then I also did runs where I just drove it around and I took the video and I recorded multiple snapshots. And then I went into RoboFlow and I labeled each of those images individually. I will also mention I did notice some issues originally with the markers, and so I ended up spending more time taking pictures of markers from the rover to give it the exact same angle that the rover would see. Training and testing with the same data as close as you can get is very important. And null images, don't forget null images.
Great advice there. Uma would like to know about how long did it take to train your version of YOLO with the data you had?
Because I have a higher end NVIDIA card, I could do the full training of the 18,000 batches in approximately 3 or 4 hours. But as you can see from the data, you could get away really with a tenth of that training and go with, say, 2,000 batches or 3,000. And then only after you're really confident with the data, you could let it run longer to see if the improvement is there or not. But you can always look at that image that's generated by the darknet to see how the convergence is, and you can look at the MAP at in the text window and really say, okay, I need to slow down, or it's fine, I'm good. And like I said, it will also save the best weights. So even if it overtrains, it won't actually use that data.
Okay. Luis would like to know, this is a question, well, Jesse and Satya both. where's a good place to start learning about YOLO? Satya?
Oh, if it is a question for me, I was giving Jesse an answer. Well, so first of all, I will, we have a webinar on the YOLO. If you want to know the theory, etc. We also had shared a notebook using YOLO 5, where you can give them the links to that, Phil, in the chat. I'm also actually, but it's going to take you 2 hours, right? That's a 2-hour series. I'm also planning to create shorter YouTube videos so that it's more compact. So that's probably coming in a month or so. But there's plenty of things about, the YOLO documentation is pretty, YOLO 5 especially, the documentation is pretty robust or pretty complete. So you can go and check that out. But check out those 2 webinars that we had gone over so that you know the theory. You also know the limitations, right? What is the essential behind it? What are the various things that you need to worry about while training these models?
Great answer. Jesse, you have any educational resources you'd like to direct people toward while you're here?
Yeah, the Luxottis documentation is amazing, so it's a good place to start. Honestly, they have a lot of links to various documentation on the YOLO, etc., which is a good start. I could only present so much today in this time, so I actually creating a blog series that's available at SparkFun, which will go over the full document that I presented for this contest, so you can see the hairy details, including these little secrets about using the flip equals 0, etc. So you can learn more about what I did.
Yeah, and we'll make sure to put the links to those SparkFun articles in the show notes. I also just dropped them in the chat here for the Zoom audience. We're getting close to time. Before we go, let's see. Next week we've got a blockbuster episode, which is the announcement of the winners of OpenCV Spatial AI contest. So please join us for that. Same time, same channel. Satya, would you like to take us home?
Yeah, thank you so much, Jesse, for this amazing presentation. And it takes courage to have a live demo on a live show. It's thank you for doing that. And I also want to encourage people. Jesse is completely self-taught. He's been building his AI knowledge over the last year, maybe a couple of years, or maybe more. But he's completely self-taught. And that should be an inspiration to all of us that he's not only won 2 competitions, he's also in the top 10 already in OpenCV Spatial AI competition 2022. So I encourage everybody who's interested, participate in these competitions. You may feel that, oh, you don't know, but it's a very good way. It's a compressed timeline where you're forced to learn, right? And you get these hardware for free. Whenever we do these spatial AI competition, you get this for free. And so there's almost no downside to participating, giving it a shot. You may end up in doing some great work of your life in this short period of time. So that's that's the message I want to give everybody.
That's right. To all the autodidacts out there, you can do it.
Right. And thanks, Phil, for organizing this. And thanks our audience. I want to thank everybody who show up every week. We are very thankful for your just meeting you in through this Zoom webinar session. It means a lot to us. It gives us a lot of encouragement because, open source and stuff like that. We are here for literally helping the community and participating together as a community.
We are here for the people.
We are here for the people. So that's it. See you next time. Thank you.
All right. Adios, everybody.
Bye.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Intel and Microsoft Azure as part of OpenCV Spatial AI Contest. Follow along with the OakDLight Contest hashtag. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.